system.out.println. Inside this, you can put byte value p, what we define space p, and same copy paste and short value yes, and put it and say what is it, the value I dot value. Yes. So what you can do, you can add this long and double values here. Long and double values. You guys can do this practice. I'll show you after when we gonna execute this logic, okay? And what is the another program we have here? Update variable values in program 2. Okay, we define variables, right? Now I want to change these values. B is a 1. Now I want to update values. So update values. How do we update? Take B is equals to 2. And then S is equals to there 1, 2, 3, 4. I'll do 4, 3, 2, 1. And then integer I is equal, that is 23, 32. And print after updating the values so that you can see here. You can say simple put print ln after updating values. After updating values, we are printing byte, short, int, float. We did not apply. So here I'll just be adding to do for you guys. Update remaining data types and print those. Okay. I'll push this into GitHub. You guys can pull in practice. Okay, that's one. Let's execute these two programs so that you'll get to know print name. Print name. This is a method calling. As I stated, main is the starting block of executing program. It will come here and print name method will be called. It will go next to print name method, whatever here, it will execute. And then call second one, what is it? Print all data types. All data types, right? And you run this program. You see here, hello John printed, and then remaining all values printed. After updating values, new value is printed, right? That way you can define a variable, and when you are updating the same variable, you have a scope to access within the function. You can execute that. In another function, if you try to access these variables, these are local to this function only. So within this function, you can access, not outside of this function, okay? And what is the another program? Write a program to demonstrate typecasting. Okay, here we can do typecasting. Let's say typecasting. As stated, right now, widening will do. Means like smaller type to assign to bigger type, right? Yes is a bigger type, and I'm assigning smaller one to this. Do you see any problem? I don't see any problem. And compiler is not showing any problem. Now we'll do another way. We will assign higher storage thing to smaller one, which is yes, short is a smaller one. Okay, I'll take integer is a smaller one and take long. Input this. Compiler is showing an error. What it is saying? Type mismatch cannot convert from long to int. Long is having higher storage compared to int. When we are trying to convert bigger value, bigger storage value to lower one, it would complain. What we talked about in whenever we have like here typecasting. Converting large size to small size, what we said, we have to define what type it is converting, right? Typecasting. Let's go to program and see what is this type. Type int, right? We could just put this here and int. And after we do typecasting, what are these values became? Let's see. We will print these two. One is short value changed. Let's put this. I'll be adding here after. Yes. And then I'll be printing this also. What is the long value? We have like long value is a bigger number. 1, 2, 3, 4, something. Let's see what it will print after converting. Let's run this again and see. If you see here, short value, whenever we are converting smaller type to bigger, byte value we updated to 2, that value is assigned to short and nothing changed. But whereas a long value is changed, long value is a bigger 1 2 3 5 2 3 something is here, right? This value converted to 86909931, which is a random number, means like maximum value where it can convert a long value to integer. Some sort of like data loss will happen. That's the reason whenever we are narrowing narrow typecasting, there's a possibility to lose a data value in that bigger value. We are losing it, right? When you are trying to fit bigger things in a smaller pocket, what happens? Whatever that pocket can fit in, it holds that only. Remaining will be dropped off. That's what it is happening. This is holding smaller capacity, but we are inserting a bigger number where it cannot hold that actual value. Whatever it max can hold out of this number, that is what it is a printing. Okay, we'll try to rerun again. Let's see if that value is changing. No, same value is a printing. That means typecasting narrowing will be holding a value which is not gonna change how many number of times you change it. Okay, perfect. And then go to another program, math library functions. Let's see what math library functions we can see. So let's say math operations, right? I have int a is equals to 2, int b is equals to 3. And now I'll be doing into b we cannot define because we used that as a variable name for another one. Into c I'll define. And now I want to do math operations. Let's say math dot, what you have here, min, max, square root, power. So what we want to do, a to the power of c means like 2 to the power 3. Let's see, math power, what it is asking, two variables, a, passing a, and the second variable will be c. And let's put this in the system.out.println. A to the power of c. And then let's take this and find the math.min, or it take math.min. It is taking two variables and giving one is the a and another one is a c. And here, min of a comma c. Let's print, run this. If you see a to the power of c, which means like 2 to the power 3, 2 repeating 3 times and multiply 2 to the 4, 4 to the 8, that's the value it print, right? And then minimum, what is the min value? What is the minimum lower number between a and c? 2 and 3, 2, it printed, right? If you want to do math.square root, let's say, we can pass any number directly. Math.square root of double in or square root of 4, let's see, and run the program. Yeah, sorry, here. Square. See, square root of a 4 is a 2. If you do 16, what will be square root? 4. These are like even numbers. Let's give square root of a 3. I'm not sure how many of you remember the square root of 3 value, 1.732. See, if you do have a math chart, you can plan square root and then different other math operations you could see. If you go to math library like this, you get, this is a math dot class, all operations what it could do, you could see. Floor means like rounding a number, right? All those operations you can perform. Round, random number generation you could do, add exact, how much you want to do. These all are like multiply exact, different operations it provided. This is the math dot class where you can see all the functions a math class in Java API provide. If you command and double click on this, if you are using a Mac, if you are using Windows, control and tap on this, it will take you to the Java API class. You can find more APIs to play around it, right? If I go to square root, what it is taking only one parameter of type double, means like you can pass any integer or a float.